To wrap up this lesson on similarity shortcuts, what we're going to do is write a similarity statement, identify the shortcut we used, and then use proportions to find the missing measure. So, do we have a similarity statement? Let's take a peek. I see angle D is congruent to angle P. I see angle I is congruent to angle A. So we are going to say that triangle, we can call this DLI, is similar, remember just a squiggle, to triangle PCA. Again, walking through the corresponding angles by angle. To figure out how long segment G is, you just need to identify the corresponding sides and write a proportion. So I can say that 4 over G is 6 over 9. You could also say, for example, 4 over 6 is G over 9. There are many different ways to write a proportion, so kind of just pick your favorite way. Again, you can use cross products. 6G is 36, so G is 6, or you could use some simplification. All right, so G is 6. Please, again, remember to check your answers, making sure your answer is making sense. Okay, for this one, write a statement of similarity and identify the shortcut that you used. Okay, and then find the length of segment AB, which is this one over here. Well, okay, I see 3 segments here, 3 segment measures, but I only see 2 segment measures here. So that's not going to be helpful for side. I don't see any angles that are congruent marked. However, angle ACB is congruent, I know this, to angle ECD by vertical angles. So I do have an angle. Now, I have to check my side proportions. I want you to notice something. This isn't a flip. You don't take this triangle and flip it over. It's a rotate, because the 13.5 is going to correspond with the 6, because those are the shorter sides. And then the 20.25 or the 20 1/4 is going to correspond with the 9. So let's double check. We'll write a proportional statement and we can use a cross product. Is 6 over 9 equal to 13.5 over 20.25? I just converted those into decimals. I'm going to just go ahead and check with cross products. This product is 121.5, as is this one. Okay, so now we're going to say triangle, let's just say ABC, is similar to, so ABC, so I'm going to go E, let's see, A, B, C. C was the shorter side. So then I'm going to go, I really got to think about this. A to B to C. I'm going to go E to D to C. Triangle EDC. By side, angle, side. All right, proportion to figure out length of segment AB. So I'm just going to do 6 over X. We'll just call this X. Equals 13.5 over 22.5. That gives me 135. X is 10. How does that feel? That feels good to me because I'll put in equals there. That looks like it's wrong if I didn't. This is the longest segment and this is the longest segment. All right. Let's look over here. Why is triangle GOS? So it kind of gave us the hint here. GOS congruent to triangle RFS. RFS. So again, I'm noticing some segments, but I'm not seeing anything that's going to give me side. But I notice parallel lines. And anytime I notice parallel lines, I'm thinking AIA. So there's my 1Z. So I see that this angle is congruent to this angle. I also have a Z going this way like this way here. So this angle is congruent to this angle. And then I also have a set of vertical angles. So yay, by angle, angle. That's a very common one. Okay, there's a lot of markings here, so it might be hard to see where T and S are. So T is this segment here. This is going to correspond to 70. Again, noticing my triangle congruence state or my similarity statement, my AIAs help me determine who goes with who. So I'm going to say that T over 70 is 36 over 90. So 90T is 2,520. So T is 28. If I wanted, I could use that in my next proportion to find S, or I could go ahead and use the 36 and the 90 again. I'm just going to go ahead and use that. So S over 48. So S over 48. So now I have to start with the 90 because I put the S on top and from the bigger triangle. 90 over 36. And that gives me S is 120. All right, so just understanding what similarity shortcuts work, and then just reinforcing how to find the missing lengths and sides of similar figures. So that wraps up lesson 7-2.